Hi everyone, I am Murali Krishna Kancheti. I have my teammate Gayatri Ravada. We are here to discuss on our AI research paper called Arcface. It is a face recognition deep learning model that was published recently in 2022, and we're gonna discuss more on Arcface. But before that, we'll know what is meant by face recognition. So, face recognition is the task of identifying or verifying one or more faces in the face. There are plenty of reasons we would want to recognize a face in an image, be it an airport security or be it some Facebook identification or like for tagging people in their images or in their workplaces. We want to allow entrance for by the authorized people. And next one will be verification task. So verification task is the task of comparing two faces and checking whether or not they are of the same person. And the next one will be identification task. It is the task of comparing and identifying a given face against a database of stored faces. The process of face recognition usually consists of three main steps. First one will be detecting an image, detecting a face in an image, and feature extraction and face matching. Even in the art phase, we follow the same recognition steps. And the first one will be face and feature embeddings. In a typical CNN model, once the face is extracted, during the training phase, the face embeddings were extracted from the image. So these embedded vectors are used for uh, recognition or classification or verification. And we'll be deep diving more into an arc face and different loss functions, and we can compare the softmax versus arc face in JSON. Okay, for now, I will ask Gayatri to take over and then discuss about the arc face.
Thank you, Murli. Yeah, as Murli already explained, what is facial recognition, what are the tasks, and how it works, and all. And we do have some traditional methods for that, as we say, like softmax and all. And but there are some drawbacks in softmax and because of that, people have chosen Arcface. It's an advanced algorithm we used for this to get a high accuracy. So as we have already seen, so first let's see what are the drawbacks in softmax and why do we choose Arcface thing. Generally in softmax, as the we have numerous numbers and they get transferred into some let's say some probabilities and all, and each object is given a probability, like every class has a probability, maybe the sum equals to 1 or something else. And once the training is completed, the class with the high probability is chosen over there in softmax. And here the categorical cross entropy, what we calculate, it gives the difference between the two distributions of the probabilities. The highest class which has been chosen and the input which have given, the distance will be calculated. So, and it is always a minimum in the process of the propagation during the training thing. So the main drawback is that it doesn't produce a safety margin, because if we need a safety margin so that we can keep that as a point and we can calculate the distance, or we can get the accuracy by classifying it. And we also want the vectors of two images, like let's say we have two people, like a same person. We need to find whether the person goes with the same class or not, and it is difficult in softmax. So, and if we see, like if we see Parseva.
Let's assume.
Yeah, if we see this example over here, as we have represented the graphs, and in softmax, the features are completely blurred. I mean, they're very close to each other, so it's difficult to classify whether the input image goes to which class. But if we see in the Arcface, we have a particular safe margins, and the distances are very clear, and the features can be easily identified. And uh, we can see some challenges in this softmax thing. So what are the challenges we faced here, and why did we get a motivation to go to the arc phase? So here, if we can see that uh, there is a facial poses, like let's say we are sitting or we are walking or we are turning our face, maybe we are wearing a mask or we are wearing some glasses or something. And in this traditional recognition, it's very difficult to recognize a person if he's having something on his face, or if his facial expression changes, or let's say he gained some weight or something, or let's say there's a lot of sun rays, or if he's wearing some sunglasses or anything, or let's say there's no light, it's a dark, let's say it's night time. So it's very difficult to get a high accuracy, or it's very difficult to guess the person. So these are some problems we faced in this softmax thing. So but in because of these problems, I think these can be rectified, and we get some advanced features in this Arcface thing. It's generally an advanced machine learning model we use to recognize a face or search a face. And if it takes a two-face images as input, and it finds the distance between them, we use Euclidean, and we have different kinds of distance algorithm, which we already represented in the mathematical equations. And it is also known as an additive angular margin loss. And it is a loss function. It's used for facial recognition thing. It will maximize the margin, as we have already seen in this diagram. It already maximized the margin compared to the softmax. And in softmax, we have this blurred thing, but in Arcface, the margin is maximized so that we can use that geodesic space on the sphere to calculate the distance for the features and all. And what are the advantages? So there are a lot of advantages to the Arcface thing, because uh, finding the similarities and identifying the similar classes thing and all, it's easy in Arcface. And it is also specially known for its robustness, because even in we have different variations like lighting or pose or facial expressions, anything, and it's very reliable in real world scenarios. And it's very effective in large scale facial recognition. And this technique, it also helps in maintaining the consistency in the performance, like the accuracy and the consistency we can maintain for a long time and effectively in the arc phase. And it has a good it also increases the accuracy by optimizing the features. And we also have an additional features like sub-center classes and all. Like it will divide the classes into the subclasses, some k number of or some n number of classes, which helps us to find the distance and to classify the images. And in this, we also have this angular margin. We have this mathematical parameter in Arcface, which is helpful to find to calculate the distance and to classify the images and all. And this is a space which is created between the classes. It will create a more distant and separable features, which can be used to identify each and every identity. And we also have an algorithm for this, which we can run and calculate this distance between those. And how generally how this arc phase works. And we have already seen about this arc phase and why we got a motivation to this. And now let's see how this arc phase works. Generally, during the training process, this arc phase will optimize the feature space for the face recognition. And next, this algorithm, it will use all this end-to-end training approach, and it ensures the joint optimization by extracting the features and normalizing those features, and creating some classification layers. And what is this feature extraction and normalization? This feature extraction, it will capture all the unique features, because we have different kinds of expressions and we have different kinds of variations here. So it will capture everything from the input image. Whatever image is given, it will capture it through feature extraction. And it will create a feature embeddings, which will emphasize the angular margin, which we have already mentioned below. And it will enhance the discrimination between the different individuals. And this uses the end-to-end approach. As we have different classification layers from the first layer, it takes the output goes to the next layer as an input. And then comes the normalization part. It is a very crucial part in the arc phase, and because it ensures that we maintain the consistency from across all the phases and different layers. And because of this normalization and the extracted features, the algorithm will minimize the impact of variations in the facial expression, such as lightening and pose. And together, this extraction and normalization in ArcFace, it form a powerful combination, allowing a precise and efficient face recognition. And as you can see the diagram here, we have the training phase and it goes through different layers. We use feature extraction and create some embeddings. And if we compare here, the first thing is softmax classifier we used, and here we also have this arc face thing, which divides the classes into sub one, create a class of similarities, and it will say us tell us whether it's the same person or not. And coming to the performance and result, and after this training model, it will pre-weight uh, using this backbone architecture, and it is tested with some data set which we have taken from Kaggle. And this is also improved when it's trained on GPU and a DPU with different batch sets. And we have a private enhancement with hash layers, we have baselines and all. And where do we use this arc face? So we have different applications. We use this in airports, immigrations and all to recognize the face and identify it. We also use in law enforcement and surveillance and attendance tracking. Employees use this for log-in and log-outs. We have these in smart cities, and even it's used in mobile devices and healthcare and all. And what are the further or future developments for this? And first thing is privacy concerns and future works. And here it also unauthorized images reconstruction using image inverting or enhancing the privacy in facial recognition models and all. And approach to protect privacy. So feature extraction and hashing. It's like a transition from the raw images, like when it's like moving away from storing a raw face images to extracting relevant features. And the hashing process is it will extract those features and they are hashed to add a different additional layer to the security. Privacy enhancement means this technique, it will ensure that if a model is compromised, then original face features remain protected. And we have a proposed algorithm here, which is adding hashing layer. It has a cryptographic hash function, transformation of embeddings, and ensuring the security. It's cryptographic hash functions. The main purpose of this is this hash function. It will transfer the facial embeddings which we have taken from the feature extraction into a hash code, and then it enhances the security of that stored information. And the transformation of embeddings, this transformation ensures the irreversibility, means it's making it difficult to reconstruct the original facial creature features. And ensuring the security in the sense these hash layers, it mitigates risk associated with the potential attacks, which safeguards both the data and the model integrity. What are the benefits of this algorithm? The main benefits are, as we have already seen, this enhanced privacy means it reduces the risk of unauthorized access and image construction, and robust against reconstruction attacks, which means despite the security measures, the model retains the ability to effectively recognize those faces. And this layer significantly reduces the risk associated with the potential model and weight inversion attacks and all. And it also preserves the model utility. And so, by concluding this, what is Arcface and why did we choose? What is the motivation to use the Arcface, and what algorithm, the proposed algorithm, and why did we use the algorithm and the advantages and all? We can conclude that we have introduced this hash layer to convert the feature embeddings which have taken from the extraction into a hash code. And then we enhance the privacy and of the face recognition system. This additionally will increase the sensitive facial information like posing, lighting, and everything. And it is further protected, and it also adds some crucial layers of security where privacy is a paramount concern. So, and this is the conclusion, the overall overview of our PPT and the project about this Arcface. And now my teammate Murli, he'll go through the code, he'll explain you about the code, and he'll show you the output and results.
Yeah, thanks, Irene. Let me share my screen.
Yeah, okay.
Okay, so we have seen what is meant by Arcface and how the Arcface is different compared to a regular softmax loss function. So we will see how the Arcface works and then how it is completely different from regular softmax loss functions. But I just want to recap the Arcface. So Arcface is an ML model that is used for facial recognition and facial search, and it follows Arcface loss functions, and it is also known as 32 angular loss margin. And let me show what are the current improvements we have done for the existing paper. So one of the main concern about the image recognition is the privacy of a person. Be it any application, be it immigration or unlocking a mobile or everything, we're using facial recognition models. So the based on the face recognition model, it will lead to privacy concerns of the particular person or particular system. So it is very useful to make the model more secured and more robust based on the privacy concern. So what we have done is, okay, I'll just go through the code and then I'll gonna share you the improvements we have done. So normally in the face recognition model Arcface, the face is converted to a face embeddings, and the face embeddings will get a feature extracted, and from the feature will be these features of the images will be later used for facial recognition and facial search. Okay, this will be the base the libraries we use like NumPy, Pandas, and FaceNet PyTorch is the deep learning framework for MTCNN and Inception ResNet backbone frameworks. And we created a custom data set that is inheriting the PyTorch data set, and this is used to pass our data set, training data set to train the pre-existing model. And here we have given the class ranges for every images uh, based on the image. Let me show you the data set we have used for training. Okay, this self test data set has more than 80 celebrities that has 16 different images for each celebrity. So we just trained all these images to the pre-existing pre-weighted Arcface model, and then we concluded few results from that. And this is the path of the data set, and then we are sending the image path from the data set, and then after getting the data set, we are getting the age, gender, ethnicity, and the name of these each images. And these each images are converted to a training data set and testing data set. We have given the data set as batch data size as 256, and we have used two workers on the GPU. And during the test, we have reduced the batch size to 2, and we have the shuffle so that the batch size will be 2, and then it will give us more secured and more robust training process. And these are different layers in the Arcface models, like flattening the given image and then converting to any to normalization. And we are using SU module, and we used ReLU and convolutive deep learning models. And this is the class for bottleneck IR, and we used IR5 background here. and it has all the pre-existed weights. We have got downloaded all pre-existed files, and then we just use the framework, and then we put all the weights from our data set and train the model. So these will be the medium layers in between input and output layer, like class flat and L2 normalization, and then we used IR5 layer in between the output layer. So during these layers, the data is the facial data is converted to a facial embeddings, and then these embeddings are stored in the list, and then this list is used to compare the given image. So even if it's a triplet loss function, there will be three images, and two images got ran, and then it will be used to search or recognize the third image. And this will be in different layers and different layers in the model. So we used IR50 model here for training purpose, and this will be already loaded. We already loaded pre-weighted model into our IR50 model of size 112, and then we used GPU. If the GPU is not available, we just try to use our existing CPU. And we're getting the inputs label, age label, gender, ethnicity, and identity label from the images. And then each image were splitted into a train data and test data. Test data with a batch size of 2, and then it is passed to a model. And from that, we processed so before that, we changed the embeddings to a tensor model, tensor type. So all the data type will be changed to tensor data type, and this data type is sent to our models here. So if we say here process tensor train, it has all the current images of the current batch size. And we're incrementing the count every time the new batch comes in. And based on this, it will find the cosine distance, or the distance between one image to all the different images in a batch, and it will find the cosine similarity, and it will store the distance. And this distance is used to classify the new image coming in. Based on the distance, the Arcface model classify the image A or image B with the image C. So it follows triplet loss function. So the basically it will give more angular margin between these two classes, and these classes also have subcenters with k subcenters, and based on the maximum k values, we will classify the image as A or B. So this is the Arcface merge login is the newest soft function compared to softmax to normalize the given image into a class A or class B. Okay, this is the existing Arcface model, and the improvement we have done is there is a possibility of inversing a given embedded values. Like if I train my image on the Arcface model, I will be getting few embeddings from that. So embeddings are nothing but the features or the values from the image. But these values can be used to inverse the image or to get the image from these embedded values. So if there is any leakage of these data, there might be a privacy concern of that image, of that person, or of that celebrity. Since we have trained the model on celebrities, there might be an issue with the embedded values. These embedded values can be used to get the person's data or get the person's future image. So what we came up is to introduce a new layer called hash layer. Since there are few layers in the Arcface model, we just introduced a new layer called hash layer that is extending torch NN model, and it will. So we need to specify the input size and dimensionality of the embeddings. After we initialize these hash layer with these input size and the embeddings values, embeddings values are passed to hash layer. So before outputting these embedded values, the output from the extraction will be passed to hash layer, and the hash layer will take the embedded values, and it will convert these hash vectors or these vector files into a hash code. So we know that hash code is more secure and it is not possible to go way back to the original image from these embedded values. So we use single way hash function. This hash function can be only used in a single way. We cannot bypass or we cannot reverse the image from this embedded image. So this is a class, we introduce a class hash layer and we are initializing with the input size and we are passing the input size of the embedded values. And then we're converting the embeddings into tensor. Since we're using PyTorch, these embedded values or these vector values are turned to a tensor. And these tensor are converted to an NumPy array, and then these are converted to a bytes into a byte format. And from the bytes, where we use SHA-256 cryptographic hash algorithm, and this algorithm is used to encrypt all this data from these embedded values. So it's very hard for the third party or third party person to get an access to the image, to the embedded functions, and then reverse the embedded values to a function. And we made slight changes. Sorry, we made slight changes to a backbone class where we are initializing the hash layer here. Since hash layer has all the embedded encrypted values, and we are just passing the new values in the backbone function. And these new values will be input layer for the next function. And we're passing this input layer and we are doing some other mechanisms in the body function. And then we are passing this to output layer. So all the hashed embeddings will be passed to a hash layer and then it will be returning all the encrypted hashed embeddings from this hash layer. Okay, so after introducing this hash layer from the forward layer, we can achieve privacy and protection to the input images. So face recognition model with privacy protection algorithm take input face images dataset with corresponding labels, and it will load the face recognition model architecture. So we used IR50 architecture, which has pre-trained weights, and we just use pre-trained weights with the existing data input values. And we defined a hash layer with that inherits NN module. The hash layer class should have a constructor to store the input size and implement the forward method to apply cryptographic hash function. So this cryptographic hash function is applied to each embeddings in tensor. As discussed, we modified backbone class. So we modified existing backbone class to include the hash layer after the original layers. And we created an instance of the hash layer in the constructor of the backbone class, and we did model training after the changes. So if the training, even if there is no training from the existing model, we try to train this new model or new changes with the existing data from the Kaggle to optimize and to know the embedded values, and we then compare the present embedded hash embedded values to previous embedded values. So we train the model on a face image dataset, considering the hash layer as a part of the training process. So coming to privacy and protection during inference, uh, input a face image into a modified face recognition model. The image passes through a original layers called input layer, body, output layer. And after the original layers, the embeddings pass through the hash layer for privacy protection. The output of the model is the hashed embeddings. To verify the identification of a face, we computed the cosine similarity between the hashed embeddings of the target face and all other faces in the dataset. If the top k most similar images include the correct identity, consider it as a successful verification, or else it is not. So the output of the model during inference is a hashed representation of the face embeddings. So privacy is protected by the one-way nature of the hash function. So the main improvement of this in this research is creating a hash class, and then we are getting a hashed faced embeddings, which is used to protect the privacy of the image or protect the privacy of the person, so that it is not possible to invert the face embeddings to the original image. And let me go through the paper here. And we discussed all the applications and benefits of hash layer, and we compared the existing Arcface model with a softmax loss function. Okay, so this is the research paper, and this will be a final report for the new implement. So we have discussed the triplet loss function, how the positive anchor image is having less distance to this anchor image compared to a negative anchor image. So it's basically a cosine similarity and the distance between these two vectors, these two phase vectors. And then we have discussed about so this is an mathematical representation of the soft arc phase function, and this will be uh, the procedure or how we can normalize the weights and how we can get the arc phase merge laws in from the softmax function. And this will be our improvement algorithm, and we used IR50 and with the preloaded train weights for the IR50 model. So this will be our algorithm, like training and then changing the class and then introducing a new hash layer and then applying SH250 hash function. And this will be our the data sets and the implementation details. And then results, we have discussed how the existing model uh, results uh, compared to our privacy protected privacy enhancement hash layer. And that's all for today. And thanks for joining. Thank you.